Okay, 1, 2, 1, 2. It's working? Seems like. Good? No? Something's off?
Ah, thank you. Helps turning it on, yeah? Very good. All this technology stuff, it's kind of not my thing, I don't know. Anyway, thanks Ben, and thanks Fabian. It's always really inspiring for me to, it's so exact and precise and clear how you explain things. I love it. It's the second time I heard the talk and I still think it's great, just as I thought the first time. And also thanks to John and wherever you're in the room here, and Tony, for Mage Titans, I'm delighted to be back. And thanks for being here and giving me your time. So I'll do my best to try and entertain you. So my talk title here is, oh no, doesn't fit. Not good start. Well, you just have to make up those missing characters. I don't know. I'll just try one little play button again. No luck. Oh well. Gee, whatever. Good enough. So stories from the other side, and that's pretty much a link bait for something more serious, right? Exploring object-oriented programming and functional programming to become a better programmer. And I figure all of you probably are that kind of crowd anyway, because you're the conference kind of going developers, right? So becoming a better developer is something we all probably want to be. Now, why am I interested in this? And what started me getting interested in functional programming is because some of the smartest guys in the PHP community at large really began digging into those concepts and those paradigms and languages, and they got so far into it they even developed their own frameworks. Like I can really recommend having a look at Lambdalicious from Matthias Veras on GitHub, and Funky, and it doesn't even fit. That's really sorry?
Want to fix it while you?
Yeah, yes, please fix it. That would be awesome.
We've been doing this act for a long time.
All right, yeah, that's true. So that was really nice to look at those code, and if they're looking at that, there has to be some value in it, right? So I'm like, well, I better look at this. Yeah, it's German. You're looking for the resolution, right? Let's collect the stuff here. There you go. Does this look better? Okay. All right, we'll get there, right? How many developers does it take?
Yeah.
There we go. So anyway, it's a classic, never fails. Completely off track now. So, right, another thing that really inspired me was reading the book, The Little Schema. It's an old book. You can find the PDF online. You can also buy it for a ridiculous amount on... This is okay. Bestätigen. It's out of print, Little Schema, it's out of print. And that's perfect for me.
1024. I'm making it worse.
You guys got it handled, I know. I'll just continue, it's fine. That book is great. I recommend reading it. It's really approachable. It's written like a children's book, but it's just to think. Yeah, thanks. That's good.
Fenster sammeln.
This collect.
Mirror display.
That's mirror display. Yeah. This. Yeah. There we go. Oh yes, thank you. Big hand of applause. Oh! That's true, I'll just do, yeah, that's a good idea. Let's just zoom up a bit, so, no, let's keep it, and I just want to zoom up without actually going to full screen, it'll work.
If it makes sense, you can change the screens.
Thank you. That's good. All right. So, 5 minutes of talking time gone. So, read this book if you're interested. Plus, I noticed that on the GitHub jobs and so on, the Scala and Haskell and other functional programming jobs are the whole web shops that were traditionally doing Java and PHP suddenly are building Scala teams or other teams in the functional programming area. So, yeah, I felt like it's kind of time to look at this. Now, I didn't really know where to start, right? So I started out by trying to figure out, well, where did it start? Where's the common ground from where I can start on this journey, right? I got to start somewhere. And turns out this term, object-oriented programming, was coined by a dude called Alan Kay. And that's him, well, that's his head. And that's the only picture I've got in this slide deck. And I'm sure he's got a body too. But anyway, amongst many other things, he created the language Smalltalk. And Smalltalk is like the grandparent of all the all the object-oriented programming languages that we know today, like Java, Objective-C, Python, Ruby, and in many ways PHP also, right? So he also did many other things, but this is a very famous quote of his out of one of his emails. So just trying to understand where are the similarities and differences, I started looking around a bit and reading, and the thing he said was object-oriented programming to me means only messaging, local retention and protection, and hiding of state process, and extreme late binding of all things. It can be done in Smalltalk and in Lisp. So if we look at these characteristics of object-oriented programming here, but then it kind of hit me that what he actually said was it can be done in Smalltalk and in Lisp. And I was like, what? In Lisp? Who ever worked with Lisp before? Right? Like, yeah, a few, right? So it's like, it's lists and recursion all the way down, right? Like, where are the objects? How can that be possible to do object-oriented programming in Lisp? How does it work with that? So that got me thinking, if my concepts about object-oriented programming actually are that accurate, right? So what is object-oriented programming? Is it about inheritance? Looking at this statement from Alan, well, messaging, local retention and protection, state process, late binding, he doesn't mention inheritance, so probably not. So maybe it's about classes, right? I mean, we write classes all day long, that's got to be OOP. But he doesn't even mention classes either. Right? So what's object-oriented programming if it's not about classes or inheritance? And that got me kind of stuck, first of all. But, well, thinking about, let's take that quote and see where it gives us. So the first thing he mentions are messaging. So for me, I haven't talked to him, but I guess that would be method calls on our objects and classes. Right, so it's like sending a message to the class or the instance, and then that object can react to that. Right, so, okay. And in a class-based object-oriented programming language, the methods of a class define its interface. And I'm using the term interface here not like in the keyword interface sense in PHP, but rather in the broader meaning where it means like the collection of all public methods of all publicly callable methods on a class, right? Because that's how I interface my code with that class. So the interface are like a bunch of related methods. And if I have a language like PHP or others that contains namespaces, well, I can put functions into namespaces, right? So I can collect related functions in a namespace. And that's actually kind of similar to methods and classes maybe, right? So maybe object-oriented programming is more about organizing and grouping classes and methods together. But then there's also this local retention and protection, right? And so that's the next part of his quote where I felt like, well, yeah, that's not the full picture, right? Objects have state. And what is state actually? How can we do that? So once again, in class-based object-oriented programming, we have, it looks something like this in PHP, right? We have class properties, we have instance properties, and that's how we handle state. But this, of course, is a very simple example. In real life, it probably looks more something like this, right? We have a whole bunch of different properties in a class, and they do all kinds of things and get their data from all kinds of different sources. Now, looking at these examples of class properties here, what characteristics do these class properties have? So we've got a literal string, right? And we have a shared object, this customer session. And just based on the name, that's probably something that's also used by different classes, right? Magento 2 style or Magento style. And then we've got an integer, but this time it's a literal value again, but it looks like it might change just based on the property name. And we've got some global state, super global variables, and this could be something from the database, so maybe in some objects or arrays or strings, we don't know, but something we get from there. So can we partition all these examples in some way? And of course we can partition them in many ways. We could go by type or memory usage or something, but what I want to focus on, I want to partition them based on whether they will change or not within the lifetime of the object. Right, so we have some state that will always be the same, and some state that might change within the lifetime of the object. So the state that might change would be the counter, or the session, right? Maybe some other class sets some properties on the session, then file system or database or some APIs. You never know what's coming out of there. And globals, of course, they represent the whole system environment, for example, so that's definitely could change. And then we have some non-changing state. Maybe this type ID from the previous example, right? The string. Will that change within the object? Maybe not. Then there's application state, and with that I mean things like, well, a request that's being processed in the scope of a front-end storefront request, probably this area scope front-end won't change, right? Or configurations. If a certain class is being instantiated by a given class name, by the object manager, based on the object manager configuration, that'll always stay the same too. Right? So some things will change, some things won't change. Now the question is, what can we do with this information? What we can do are pure functions. So what are pure functions? Very good. They don't change any state. And, well, what I said, they don't cause any side effects. So I think probably you said don't change any state would be that part, right? They don't cause any side effects. They don't do anything outside of the current function scope. And given the same arguments, they always return the same results. That's the definition of a pure function. So what are side effects? Side effects means changing the state of non-local to the function scope. So that could be other objects, or it could be global variables, any of those. Then database, network, or file system access, that's non-local state. Throwing exception is a side effect, or forking a process, for example, is also a form of side effects. Now, no side effects was one part of pure functions. What was the other part? The other part of pure functions is, given the same arguments, they produce the same result. And a function that always returns the same result for the same arguments is called referentially transparent. And that's just a fancy name, right? Let's not focus on some programming terms or buzzwords. Just keep the concept in mind, right? Same arguments, same output. So every pure function is referentially transparent, but not every referentially transparent function is a pure function because it might cause side effects. So a referentially transparent function must not use state that might change, because otherwise it wouldn't be referentially transparent, right? Okay, so why should we care about this? Like, blah, blah, blah. No, what's good about this, right? It's good because pure functions offer a lot of benefits. For example, they're easier to think about. I only have to keep in mind which arguments are being passed into the function and what type of result should be returned. I don't have to worry about the state of the database or a session or global variables or anything else. It just doesn't matter. It's completely out of the picture. So they enhance reasonability of the code. They're easy to break apart because if I have a pure function and break it apart, well, I get a bunch of smaller pure functions. So that helps refactoring the code and keeping it in check. So it enhances decomposability. And another nice characteristic of pure function is I can combine them. So I can take these small functions and use them together, and I get another pure function. So that increases composability and reusability. It's easier to show correctness. I can normally pretty easily test a pure function, since I don't have to worry about creating big fixtures in the database or virtualizing the file system or all this other stuff, right? Because, well, just the arguments. I just pass what is needed into the function. And they're easy to parallelize, and that's something that isn't really that important for us PHP developers at this point in time, but I think that might change in future. So we don't have to worry about any locking or something, because pure functions just operate on their local state. So that's all nice and peachy, but in the real life we have to deal with things that change, right? How can we deal with changing state? So one way we can treat them in order to realize the benefits of pure functions is we treat objects as snapshots of one moment in time. So basically we take an object with some state and we say this object represents the state of the world in this moment. So we put time into the equation here. And in this moment the state will never change, right? Because it's one moment in time. So if a change occurs, that means time must have passed, which means this object doesn't represent the current state anymore, but we need a new object if we keep time in the picture. So this change that happens over time, we can represent that in two ways. Either we modify the object properties, right? We mutate it, we change it, or we create a new instance to represent the new state. So this gives us the option, if we choose not to modify the object but rather create a new instance, that gives us immutable objects. So they don't change, which means we can use them inside of pure functions. So for example, what happens when admin logs in? So if we have an admin user instance, log them in, and we get a new state of the admin. Very simplified example here, right? So we just create a new instance with a different state for the logged in property. Now we have two objects, one representing admin in logged out state, one representing him in logged in state, him or her. So the question here is, of course, that's all easy, but what do we do if my object that I'm working on right now needs the current state of a different class, of a different object, like the session, for example, right? The object that I've got might be outdated. Maybe somebody else changed it and it's a new instance, but my object isn't modified. So well, how do I do that, right? So either the object that I'm working on would have to be recreated with the current version of the other instance that I need, or the alternative is that other instance has to be passed in as a method argument. Those are the two choices we have. So an object-oriented style, that would look, maybe we have some kind of authorization manager, has access, and we pass in a page and an admin, and we get the Boolean out, right? So we pass in whatever might change. Or in functional style, we have a function, right? And we pass those values in, and we get the result. So I get that much, but in reality, my code tends to need more data. So there are many more arguments. So let's try to see how we can reduce the number of arguments, right? And in object-oriented programming, of course, if we create an instance of a class, we pass some data that needs it to the constructor, right? Dependency injection, constructor injection, and we bundle that state into the object. So here we are assigning the authorization manager and the page, the current page, to the object, and then we just can call has access with an instance of the admin, and it will give us our Boolean. So now we, instead of two arguments, we just have a single argument. Right? Simple. Same for functional programming. Right? We just create a closure. Function just takes one argument. We import and bind the other values we need into the function, and then we can call the function with a single argument. Very good. So we can reduce the number of arguments by bundling that state with the classes. And of course, we can also remove all arguments, right? We can take the previous example, bundle in the admin, which in effect would give me something like a logged in admin dashboard authorization instance, because now this class contains both the page and the admin in the logged in state and the authorization manager. And we can call the method without any arguments, and we can do the same thing in more functional terms too. We create a function, bind whatever we need into that scope, and we get a new function without any arguments. So we can bundle state and functions without classes, you might have noticed, right? Or in LNK's term, we bundle state and process without classes. So when I realized that was like, wow, my mind's blown. We're doing object-oriented programming without classes in PHP. I think that's amazing. I don't know. I don't know about you, but for me that was like, oh boy, something like felt like a real realization right there. Right? No hands, no, no classes. But it fulfills all the characteristics of object-oriented programming. So getting back to our state management, we have a choice here. We can either pass state into methods as arguments, or we set the state as object properties. And the more volatile these objects are that we're working with, the more often we have to recreate the object if we want to have pure functions, right? We have the choice. We can also modify the object and treat them as mutable object, but then we lose all those benefits. So, one lesson from functional programming would be that we can use in object-oriented programming would be it's valuable to distinguish between mutable and immutable object properties. And this is one of my favorite quotes from a very smart guy, Rich Hickey. He's the creator of the language Clojure. And he wrote, mutable stateful objects are the new spaghetti code. And that quote actually isn't that new. It's like, I don't know, 7 years old or something. So we're slowly catching up. All right, so to summarize, yes, I think concepts from the functional programming world can be very valuable and can certainly be applied within object-oriented PHP. And we certainly can benefit from designing our object-oriented code in a way that it exhibits the properties of pure function, even if there technically isn't a pure function, because we haven't got language support. PHP allows us to modify everything, right? But by discipline, we still can have all those benefits pretty much. But we barely scratch the surface here. Pure functions is just one very fundamental concept of functional programming, and there are so many patterns and approaches to problem solving in functional programming, and many of them are just as applicable in object-oriented programming, because as it turns out, OOP and functional programming actually isn't that different, right? They're very, very closely related. It's just how we treat the code. And then there's this thing if language supports something like immutability or not, but we can realize many benefits without that. And many of those functional paradigms have fancy names like monad and monoid and Y Combinator or trampoline recursion and such, but that scares me. I don't come from a mathematical background at all. So at first it freaked me out a bit. But looking at the code, I realized it's not that bad. It's just code after all. It's not magic. So even though they have fancy names, yeah, it's fine. I can deal with it. So building these slides, I learned something about object-oriented programming, and I hope you found it interesting too. So if you have any questions, I don't know if I've got time or not. I'm completely off track. I've got time. Well, a couple of questions maybe. Otherwise, please, I'll be around all day, of course. Please feel free to come and pull me out of any conversation at any time and chat to me. I would be very happy to meet as many people as possible. And I'm always happy to talk about these kind of concepts. So I hope you found it useful and liked it. This was a new talk, by the way, and I really don't know what you think. So I would be delighted to get any kind of feedback on Joined In. All the talks are on Joined In, so if you go there, look for Mage Titans, you should be able to rate the talks there. On Twitter, or if you don't want to talk right now, come to me and talk to me later. I would really like to hear what you think about this. So, thank you.